So here we're going to talk about what an average value of a function is. That's pretty simple to talk about. And then from there we're going to get a formula. This is maybe the easiest section. I feel like I say that too often. I'm going to stop saying that now, I think. Yeah, I'll stop saying it. So let's just think about what is the average value of a function. So suppose we have a function f of x. So suppose we have a function f of x. The average value of f of x is simply the average height or the average y value of that function. So like if you were thinking about the average score on a test for a class, you would add up all of the scores and then divide by the number of scores that there are. Well, it's the same idea for the function, except for we have an infinite number of things to add up, so we have to do something kind of different. But for an average test score for a class, that's like saying, well, okay, say the average is 71%. That means most people scored near 71%. It averages out to 71%. I mean, it doesn't really mean that, but it means like, okay, overall the class, as a class, it's to describe the whole entire group. The class overall did 71%. Even if some people did like super great and some people did super terrible, it averages out to be like a way to describe the central tendency of the class. This is the same idea, except for we're talking about the average height or the average y value, because the y value is just the height. So if I had a picture and say this is f of x, and I want to know the average value of f of x from a to b, I just want to know what the average height is here. I mean, this is kind of a bad picture, but I want to know what the average height is. Now, normally I can just pick a couple of y values, or sorry, a couple of x values, which would give me a couple y values, right? This is like discrete data. I can get the average of this by getting all these y values and adding them together and then dividing by 4. But if I wanted a more accurate representation, I could just get a bunch more y values, right? So then now I would get these y values by plugging in whatever x values they were, and I would, I guess 1, 2, 3, 4, 5, 6, 7, 8. I would add those together and then divide by 8. Well, I'm not doing that anymore. I want to do an infinite number of these y values. So instead of dividing by 8 things, because I don't have 8 discrete points, I have just however many units are between b and a. So I'd have to divide by the interval b minus a. We'll talk about that, and it's really just a formula, but we'll talk about it in a second. What I'm going to try and do is relate the average value of a function to the average y value, and then I'll relate it to the area so I can use an integral. So that's what I'm going to do first. Then I'll give you a formula. You don't really have to repeat this. You don't have to know how to do this, but I'm just going to show you what it is. Like all you have to do is remember the formula. So I just changed my function a little bit. Oh, look at that. Isn't that a nice bell? Isn't that nice? Okay. The average y value here, I mean, I have y values between whatever this is and whatever that is. So the average may be in the middle if it's increasing consistently. But the average height would be somewhere in the middle, right? So this, a lot of people say f average. That height, I'm going to say, I don't know what it is, but I'm going to say that's the average height right there. And I'm going to relate it to area. So if I had this average height, then I could calculate the area here by just having a, whatever this distance is, b minus a, times the f average. That would be an approximation of this area, the area underneath the curve, right? So this is just kind of like a way to remember your formula. Actually, it's not even a way to remember your formula. It's hopefully a way to make sense of it. But I'm relating it to areas because part of the formula is an integral. So if I had my average value of the function, that would be this height, and I multiply it by this interval, that distance there, then I would get this area of the rectangle. But that area approximates the area of the area below the curve. So what is the exact area below the curve? So this is like approximate, well, it's supposed to be like the central tendency for that area. This is not making any sense, but I'm going to continue on anyways. The actual area would be from A to B, and then I would have f of x dx. If I wanted just the average value, I would divide both sides by b minus a. So this would be like 1 over b minus a. And then I would get the average value of the function, not just the average area. So f average, the average value of a function would be 1 over, this is the formula that you have to know. Sorry if that was confusing. It was kind of weird. I don't know why I did that. But this is the formula that we're using. It's really, really straightforward. So I'm going to give an example real quick, and then we'll be done with this. That's the formula that you need to know. So average value of a function is just the area under the function divided by the interval, divided by the distance of the interval. That just gives you the average value. So let's have an example. So here it says, find the average value of f of x equals x squared plus x plus 1 on the closed interval from 1 to 3. So the average value, we're just using that formula. That's just, well, the integral from 1 to 3, and then the 1, and then the 3 minus 1, because this is b, this is a. So this is 1 to 3, there we go, of f of x, x squared plus x plus 1 dx. And then we just do this integral. This is 1/2 times the integral from 1 to 3 x squared plus x plus 1 dx. And then I'll take the antiderivative. So this will be 1/2 times x cubed, right? Antiderivative, you add 1, divide by 3, x cubed plus x squared over 2 plus x, and evaluate that from 1 to 3. 1 to 3. And let me just double check. If I take the derivative, I would get x squared, yeah, x and 1. Okay. So I'll plug in, this is a 1/2, again! Sorry. And then plug in the 3, that would be 27 over 3 plus 9 over 2. Oops. Plus 3 minus, parentheses, 1/3 plus 1/2 plus 1. And then eventually I'm going to multiply that by 1/2. But here, let's see, I would distribute this negative. I'm going to combine the common denominators. This would be 27 minus 1. That would be 26 over 3. And then I'll do this and that. 8 over 2 minus 8 over 2. And then 3 minus 1. That would be 2 plus 2. So this would be, I guess I can simplify this, and then I remember I got to multiply by 1/2. So then I have what, 26 over 3 minus 4 plus 2, so that's just minus 2. I'll get a common denominator by multiplying by 3, so it's minus 6. 26, and again, still multiply by 1/2. 26 minus 6 all over 3, that's 20 over 3. I feel like I'm doing something wrong. Let me double check. Oh, there it is. This should be plus. Yeah, just kidding. So that's different. And then, so 1/2 times 26 over 3, this is 4, 5, 6, so it's plus 6. And over 1 times 3 times 3. So that's 18. Plus 26. So that equals 44 over 3, which is, and then divide by 2, that's 22 over 3. There we go. Yeah, that's it. Average value of a function. We could have just started the video from here. This is the formula. It's pretty straightforward. There you go. Have a good day. I'm leaving.